So this lecture goes through each of the tasks for a typical environmental flow assessment. Now, there are a number of different types of environmental flow assessment at different levels of detail, and this is based mainly on the holistic methodologies such as the building block methodology as a typical method, but most of the tasks are quite common to most of the more detailed methods. Okay, so this gives an overview of the different tasks, and I'll go through each of them in more detail. So I've called Stage A scoping, where one's looking at the river generally, doing a general survey of the river to get an idea of the whole study area of interest. Then into Stage B, preparation for the environmental flow assessment workshop with a number of different tasks, which I'll go through in detail: appointing the assessment team, zoning the study area, habitat integrity assessment, selecting sites for detailed studies, then the surveys and measurements, the field tasks, the ecological and social importance and sensitivity, defining reference conditions, defining present ecological status, and defining environmental objectives. Then Stage C, the actual environmental flow assessment workshop, where the flows are actually assessed by the different specialists. Stage D is a negotiation process where the recommended flows are then, the recommended environmental flows are then added in with the user requirements in terms of domestic, agricultural, industrial, and so on uses, to see whether the flows in the river can meet all those requirements and the environmental flows, and if not, obviously there have to be negotiation and compromises. And then finally, implementation and compliance monitoring, which is a long-term, basically indefinite part of the process. Okay, so the scoping. This would be an initial assessment of the area of interest to try to identify issues of particular importance and to draw up an initial plan for the assessment. This phase can also include a first stage environmental flow assessment using lookup tables such as the Tennant-Montana methodology, or a hydrological analysis such as the index of hydrological alteration, or an extrapolation approach such as Dennis Hughes' desktop method, to provide a reconnaissance level estimate of the probable volume and distribution of water required to meet a variety of environmental conditions. Okay, so after this initial scoping, the preparation for the assessment workshop, there are 10 steps in this preparation, and they involve all the different specialists, sometimes working cooperatively, sometimes carrying out tasks separately. So the first task, to initiate the assessment, to decide on the level of detail and define what methodology is going to be used. And this task is going to depend on the urgency of the problem, the data availability. In other words, if you have very little hydrological data, then it probably isn't worth spending a lot of time and effort getting very detailed ecological data, because the lack of hydrological data confidence is going to govern the confidence of the results. The resources available, time, money, expertise, the importance of the river in terms of environmental issues, the present and future river use, the complexity of the system, and the difficulty of implementing the flows, whether you have structures which can release flows, whether you've got a good demand management policy framework, and so on. Okay, so that's initiating and deciding on the methodology. Appointment of the assessment team, which will typically be led by a project manager or coordinator, who will have an environmental flow assessment facilitator, somebody who understands the whole process, who understands where the different disciplines fit in, and then the various specialists, a hydrologist, a hydraulics surveyor and modeller to provide the rated cross sections, geomorphologists to deal with sediment and channel shape, water quality specialist, and then a variety of ecologists, usually a fish ecologist, benthic invertebrate and riparian vegetation, but also possibly water birds, amphibians, phyto and zooplankton, microflora and so on. And then a sociologist and a resource economist to look at the various aspects of people use of the river and the costs and benefits of different management strategies. Task 3, zoning the study area to identify reaches of the study river in which the physical and ecological conditions are likely to be similar, so that they can be dealt with as particular sections of the river for which the flows can be recommended as the same. Those zones are usually defined by major changes in channel size, hydrology, geology, gradient or land use, where tributaries come in and so on. So detailed studies will be based on sample sites, and the ideal is to locate one site for each zone that will characterize the conditions throughout that zone. Okay, here's an example of zonation for the upper and middle reaches of the Ganga River in India, where we ended up with 7 different zones from Gangotri up in the Himalayas down to Kanpur in the middle reaches. 5 zones mainly defined in terms of gradient of the river as it flattened out, reaching its floodplain sections, but also defined by things like where there were major barriers, barrages and different land uses and so on. Okay, habitat integrity is really an overall survey of the condition of the section of the river of interest, and the aim is to classify the section in terms of how much they've been modified from natural conditions. Often done, as this one was, through a helicopter video survey, in this case with the Sabi River, looking at 5-kilometre river sectors, where the dark green section next to the Mozambique border is natural riparian habitat integrity, the riparian habitat being the colours below the river channels, and the in-stream habitat integrity being the colours above the river channel. So the greener it is, the more natural, and the browner it is, the more degraded. And this just provides an overall view of the river, so that where you then put the sites marked here in red as IFR 1, 2, in-stream flow requirement 1, 2, 3, up to 8 sites on the main Sabi and its tributaries, so that where these sites are located can be representative of the different zones, and we know what's going on upstream and downstream of them. So that's the overall habitat integrity. Then site selection within each zone, which will, main criteria will be ease of accessibility, the habitat diversity for the ecologists, the sensitivity of habitats to flow changes. So for instance, river pools are not normally very sensitive. The level will more or less stay the same until the flow stops, but riffles and rapids are very sensitive, and will the amount of habitat and the depth and the velocities will change with changing flows. The suitability for measuring a rated hydraulic cross-section and for modelling discharges, velocities and wetted perimeter at different water depths. The proximity to a flow gauging site, so that we can know what the flow's coming down the river without having to estimate them each time. Representation of conditions in the river zone. Is this a typical part of the river zone? Is it a critical part of the river zone? Is it sensitive to flow changes and so on? And so is it a critical flow site, i.e. where the flow will stop first if discharges are reduced, so that you're getting the most sensitivity to flow changes. Okay, then surveys and measurements. Here you've got the different biological surveys, fish communities, benthic invertebrates, riparian vegetation, and the other groups if necessary. Hydraulic survey and analysis to provide the rated cross-sections or habitat modelling. to provide the link between ecological knowledge and the flows required to maintain the habitats, and that the accuracy of that hydraulic survey and modelling is crucial to the confidence of the overall process. The hydrological analysis, similarly, the flow record, hopefully a long historical flow record so that we know the different flows that are happening in the river channel and the floodplain, and is used to check the recommended ecological flows, that they're within reasonable limits of the flows expected in the river. The geomorphological survey to analyse channel morphology and predict consequences of changing flows on sediment input-output, and therefore on the channel shape, substrate types and habitat types. The water quality analysis. Water quality requirements are assessed in parallel with the flow requirements to identify point and diffuse runoff impacts in order to be able to predict what will be the water quality changes with differing flows. And then the social surveys, there are really two types of survey associated with the kind of building block type methodology. First of all, the identification of people who are directly dependent on a healthy riverine ecosystem, to identify aspects of the flow regime that are important for each use. So maybe for recreational or commercial fishing, whitewater rafting, people who are using water directly from the river, who are watering their animals in the river, other recreational aspects and so on. And then the second one is a consultation and capacity building with all relevant stakeholders or representatives of stakeholder groups to identify preferences for the management objectives for the river. It's a very important part of the process to make sure that you've got buy-in from the stakeholders. So consultation and capacity building with all stakeholders to identify preferences for the management objectives for the river is an overarching framework for the whole process. Okay, here's just an example of the characterization of a particular site in the Ruaha River in Tanzania, just to give an example of the kind of specific site on which the detailed work would be done on the fish, riparian vegetation, geomorphology and so on. Okay, and there's some of the fish sampling being done at that site. Okay, task 7, ecological and social importance and sensitivity. The ecological importance is a measure of the priority of the area of interest from an ecological perspective, and the social importance is a measure of people's dependence on the healthy riverine environment for goods and services, recreation and cultural and spiritual values of the river. So that would be an important part of providing the framework for setting the objectives for the environmental flows. Task 8, defining reference conditions, the background template, which would usually be natural conditions, but might be in rivers which have been modified over a very long period, and so the natural condition is just simply not a realistic reference point to go back to, in which case one's got to decide at what stage to set the reference conditions in terms of the utilisation of the river. So they'll provide a baseline against which to judge how much the river has been modified, and in order to decide, has it been too much modified and do we need to improve it, or is it all right to just maintain present conditions? Okay, task 9, defining present ecological status. The purpose is to compare present conditions with the reference conditions to measure how far the river has been modified over time. And this process provides the basis for the definition of the environmental objectives. So here's an example of a table where we're looking at different components: water quality, geomorphology, riparian vegetation, fish, aquatic invertebrates, and an overall what we've called eco-status in terms of the present ecological state, how much it's changed from the reference condition, in terms of the long-term change. So in other words, if the management of the river goes on as it has been, what would be the change over the long term? And there you can see in terms of the geomorphology, that the prediction would be that there's a negative change where the present ecological state is a BC class in terms of A being natural, B slightly modified, C moderately modified, D significantly modified, well, it doesn't go beyond that in this case, but it could go to E or F, which are very severely modified. So the long-term change for geomorphology would be predicted that it would change from a BC slightly to moderately modified to definitely moderately modified. The fish component presently at a moderately modified C class with present management conditions would deteriorate to a D or severely modified condition. Okay, so that's the long-term change. The ecological importance and sensitivity, which is a general, not component by component assessment, would be high in this hypothetical case. And from that, the ecological management class, or what would be the class that the specialists would consider to be the requirement for the environmental flows. And in this case, you can see that to maintain the present class in most cases, in fact in all cases, would be the objective. So the present ecological state is felt to be sufficiently good to meet the stakeholder objectives, but in order to meet those objectives, one would have to bear in mind that there are negative changes in the long term going to go on unless there's an improved management process. So that's a summary of those aspects of the assessment. All right, so 10 to define the environmental objectives. There's no single correct environmental flow for any given river. The question is how much impact is acceptable and what are the goods and services that the various stakeholders expect from the river, and what objectives could be achieved or should be achieved by managing the river. Okay, then stage C is the environmental flow assessment workshop. Depending on what methodology is being used, this process may take many different forms, but essentially different comprehensive methodologies, such as the building block methodology, such as the drift process, represent different ways of processing and analysing the same information. So you should get the same answers if you're using the same information and the same specialist, no matter what method is being used. And an example process, let's say for the building block methodology, at the assessment workshop, flow recommendations are decided by the whole group of specialists. For each recommended flow, and that might be dry season base flow, wet season base flow, higher flows and floods, the specialists consider what habitats should be inundated, current velocities will be needed, river width and so on, be required to meet the objectives to provide the habitats for the biodiversity and the different uses of the river. The hydrologist then checks if the recommended flow is realistic in terms of the flow patterns experienced at that point in the river, and at the environmental flow assessment workshop, the water quality specialist will respond to the recommended flows by estimating or predicting the consequences of those flows on the concentrations of various water quality parameters to indicate whether water quality guidelines are going to be met. Okay, this is just a group of pictures of different rivers and different stages of the process of the field work and the assessment workshop for the Mara, top left there, the Ganga River on the top right, the Wami Ruvu in Tanzania on the left, and some of the upper reaches of the Amazon in Ecuador on the right, on the bottom right. Okay, stage D is the negotiation. So once the environmental flows have been assessed, this stage addresses the analysis and decision-making process. It's at this stage that the environmental flows and the user requirements, agricultural, domestic, industrial, so on, are integrated into the analysis. So it's looking at whether the river can accommodate the user requirements and still maintain the environmental flows or not. If they can't be met, then one has to go to the hydrological yield analysis, calculates the likelihood of being able to maintain the environmental flows and supply the user needs in wet and dry years. If all these requirements can be met, then fine, the water allocation plan can be agreed. If not, there has to be an analysis of different scenarios in which either some of the user requirements are given a reduced level of assurance, or the environmental flows are compromised. So different scenarios are developed, allocating a series of assurance levels to different users, such as maybe irrigation requirements during the dry season with an assurance of 60%, so that 6 out of 10 years on average the farmers would get all their requirement. 4 years out of 10 they would have to make do with rather less, and so on. And similarly, the environmental flows might be provided, but at a lower assurance level. So then somebody has to make the decision to implement the environmental flows, and that may rest with different authorities depending on the scale of the river, whether it's international, national, regional, so on, and the governance protocols of the basin. In areas where there's competition for scarce water resources, the best chance for a decision in favour of implementation of environmental flows will depend on a high confidence assessment and on the support of the majority of stakeholders. Okay, stage D, implementation and compliance monitoring. This is the culminating step of the process, but lasts indefinitely. So methods of implementation will depend on the availability of storage structures or interbasin transfers, or the potential for demand management on any specific river. It's effective to apply an adaptive approach in which releasing some water down the river by whatever means are currently available is accompanied by an effective monitoring operation that allows for the response of the river to the flows to be assessed, so that the objectives can be revisited in terms of the experience of actually implementing flows and monitoring, and maybe the flows can be refined either upwards or downwards depending on the results of initial implementation. So in terms of the South African policy, there are 4 levels of environmental flow assessment. There's a desktop model which extrapolates from detailed previous assessments in terms of the different flow types of different rivers, but is basically a computer simulation with a fairly low confidence. It only takes half a day to do, so it's very quick and can give an initial reconnaissance level answer. If that is not agreed to, if there's some kind of potential conflict, then rather than trying to defend that assessment, one would immediately go to the more detailed methods. The next method would be a rapid, which would be the desktop model plus limited verification, field surveys and so on. Low to medium confidence, maybe 2 to 4 weeks to get an answer. Again, the intermediate level is at more detail and is a scaled down holistic method with limited hydraulics, providing, let's say, medium confidence answers, taking not more than 60 days, since in terms of the South African licensing system, anybody applying for a license to use water is required to be given an answer by the authorities within 2 months. And then the comprehensive, where you've got a very important river, where you've got a lot of different users and a lot of potential conflict, and you need very high confidence answers,